Hello students, I am Mohammad Asim. In last lecture, we did question number 3 and question number 4 of exercise 4B book 3 7th edition, and we applied some more laws of indices, but still one law is left. What is one law? Law number 8. We call law number 8 is rational indices. What is rational indices? It means if you have some fractional power like a to the power 1 upon n, so we can convert 1 upon n in terms of root a with n. This a which is under the root is called radicand, and this n which is outside the root is called index. So a to the power 1 upon n is equals to nth root of a. What we call this? Nth root of a. Now, how to use this law to evaluate our indices? See question number 5. In question number 5, we have to evaluate each of the following without the use of a calculator. Student, this topic indices and questions of indices always comes in paper 1, and you know paper 1 means where calculator is not allowed. So we have to evaluate each and every part of question number 5 without the use of calculator. See part A, 196. We have to find the value of square root of 196 without the use of calculator. So we have to apply this law. You know student, this is square root, and square root means something to the power 1 upon 2 always. So if you have this sign without the index number, it means this is square root, and square root means the power is 1 upon 2. So first we have to write 196 to the power 1 upon 2 instead of root. Then we have to find a number whose square is 196. Why we need square? Because we want to cancel that square to this 2. Obviously 14 square is 196 because 14 square means 14 multiplied by 14. 14 14s are 196. So write 14 square instead of 196, and this 1 upon 2 remains 1 upon 2. And students, you know, according to the third law of indices, if you see power to the power, so power to the power is always multiply. If you see a to the power m and the power n, then you always multiply m by n, you will get m into n. Similarly, here 14 to the power 2 and the whole power is 1 upon 2 means power to the power is always multiply. So 2 multiplied by 1 upon 2 is 2 cancelled by this 2, 14 to the power 1, that is 14. So final answer of square root of 196 by 14 by using this law, rational indices. See part B, 125 with index 3 can be write 125 to the power 1 upon 3, because if here is n, we have to write 1 upon n. If here is 3, we have to write 1 upon 3. Every number, if you see any number over here, you must convert the number into 1 upon the number. So this is 3, we have to write is 1 upon 3. Now I want to cancel this 3. How I cancel this 3? I will find a number whose cube is 125, and obviously 5 cube is 125 because 5 cube means 5 into 5 into 5. 5 5s are 25, 25 5s are 125. So we have to write 5 to the power 3, and this 1 upon 3 is still 1 upon 3, and apply the third law of indices Power to the power is always multiply. Therefore, we can cancel this 3 by 3. Answer is 5 to the power 1 means 5. So, cube root of 125 is 5. I hope you understand. Now, see this. Root of 1 upon 32 with index 5. Apply this law. Eliminate this root. So, without root, this is 1 upon 32 to the power 1 upon 5. This is n. So, this is 1 upon n. This is 5. So, this is 1 upon 5. Now, find a number whose power 5 is 32. Very easy. 1 upon, we can write 32 to 2 to the power 5. 2 to the power 5 means 2 into 2 into 2 into 2 into 2. 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32. We can write 1 upon 2 to the power 5. Now apply law number 5 on this indices. What is law number 5? If we have a upon b to the power n, we can apply a to the power n and b to the power n. So here 1 upon 2 to the power 5 to whole power is 1 upon 5. Then apply this 1 upon 5 on 1 and this 1 upon 5 on 2 to the power 5. You know, student, everything, if you see any power of 1, 1 to the power 2, 1 to the power 0, 1 to the power minus 5, 1 to the power 1 upon 5. So anything to the, if you see 1 to the power any number, the answer is always 1. And see this, power to the power is always multiply. So 5 multiplied by 1 upon 5 is 5 cancelled to 5. The answer is 1 to the power 1 upon 5 is 1 and 2 to the power 1 is 2. So the final answer is 1 upon 2. And I am not using calculator because calculator is not needed. It's very easy question. See part D. 16 over 81 with index 4. First, we can convert this 16 upon 81 is the whole power is 1 upon 4 by applying this law of indices. Now, we have to find a number in both numerator denominator whose power 4 is 16 and whose power 4 is 81. So 2 to the power 4 is 16 because 2 into 2 into 2 into 2. 2 to the 4, 4 to the 8, 8 to the 16. So we have to write 16 is 2 to the power 4. Now 81. 81 is 3 to the power 4 because 3 to the power 4 is 3 into 3 into 3 into 3. 3 3 is a 9, 9 3 is a 27, 27 3 is a 81. Now apply this 1 upon 4 on this numerator and on this denominator. So this is 2 to the power 4 and whole power is 1 upon 4. This is 3 to the power 4 and whole power 1 upon 4. Apply this law, power to the power is always multiply. So 4 into 1 upon 4 is 4 cancelled to 4 and 4 into 1 upon 4 is 4 cancelled to 4. What is remaining over here? Only 2, and what is remaining over here? Only 3. So this is our answer. Hope you understand. This is question number 5. It has only 4 parts and I have done all parts. See question number 6. Rewrite each of the following in the radical form and hence evaluate the result without the use of calculator. In these questions, there are 2 requirements. One is same as we did in question number 5 and the other is first convert the given number into radical form. It's very easy. This is 81 to the power 1 upon 2. If we apply this law, 81 to the power 1 upon 2, what is this? A to the power 1 upon s is a with index n. So 81 means root and 1 upon 2 means square root. For square root, no need to write 2 over here. But if you see any other number instead of 2, we must write. But for 1 upon 2, no need to write, because it is obvious if there is no number, the number is 2. Now, this is the first requirement. What is first requirement? Rewrite each of the following in the radical form. So first requirement is fulfilled. This is first requirement. We convert this into radical form. The second requirement is same, and hence evaluate the result. How to evaluate the result? This is 81. We can write 81 into 9 square, because 9 9s are 81, and apply law number 3. Power to the power is multiply. So 2 cancel by this 2. 9 to the power 1 is 9. So this is our answer. Come to part B. Part B is minus 27 to the power 1 upon 3. Again we apply this law. A to the power 1 upon n is root a with n. So minus 27 to the power 1 upon 3 is minus 27 root with index. What is this? This is 3, index 3. So this is the first part. Each of the following in the radical form. It converted into radical form. Now the next part is evaluate the result without the use of calculator. How to evaluate? It's very easy. Find out a number whose cube is 3, because we need to cancel this 3. Obviously, we have to write a number whose cube is 3, that is 3, because 3 cube is 27. Why? 3 cube means 3 into 3 into 3. 3 3 is a 9, 9 3 is a 27. So the answer is minus 3 to the power 3, and this is 1 upon 3. So this 3 cancel by 3, minus 3 to the power 1 is minus 3. This is our answer. Hope you understand. Come to part C. Part C is 16 to the power minus 1 upon 4. Student, 16 to the power minus 1 upon 4. First we have to convert this negative indices into positive indices. Which law we have to use? Law number 7. Law number 7 says if you have a to the power minus number, we always write a to the power minus number is always 1 upon a to the power positive number. So if this is 16 to the power minus 1 upon 4, we can convert this minus 1 upon 4 by writing 1 upon 16 to the power 1 upon 4. This minus 4 becomes plus 1 upon 4. So we applied, in first part we applied law number 7. See, 1 upon, convert this into radical form. How? This is 16 and this 1 upon 4 becomes index 4. So first requirement has fulfilled. Now the second requirement is to evaluate this. It's very easy. Come again on this step. We have to cancel 4. Now we write a number whose power 4 is 16. Definitely 2 power 4 is 16. Why? Because 2 power 4 means 2 into 2 into 2 into 2. 2 to the 4, 4 to the 8, 8 to the 16. So we have to write 2 to the power 4. And this is 1 upon 4. Now cancel this 4 by 4. The remaining is 1 upon 2 to the power 1, which is 2, and 1 upon 2 is your final answer. Now come to the power, come to the part D. Part D is 4 to the power 1.5. So if you see power in decimal, first try to convert decimal in fraction form. How to convert? See this. This is 1.5, power 1.5. So we can write 1.5 in terms of 15 upon 10. And 15 upon 10, if we cancel this 15 upon 10 by 5, 5 3 is a 15, 5 2 is a 10. So 1.5 becomes 3 upon 2. Now your question, 4 to the power 1.5 is converted into 4 to the power, what is 1.5? 3 upon 2. So we write 4 to the power 3 upon 2. Now second is, this is 4 to the power 3 upon 2. We can write this 4 to the power 3 upon 2 is 4 to the power 3 and whole power 1 upon 2. This and this absolutely same, because if we multiply 3 into 1 upon 2, we will get again 3 upon 2. But why we convert, why we write this 4 to the power 3 upon 2 in this form, 4 to the power 3 and whole power 1 upon 2? Just because this 1 upon 2 means square root, and this 4 to the power 3 is radicand. Radicand means is under the root. So 4 to the power 3 and the whole power 1 upon 2 become 4 to the power 3 with square root. Why we need this? Because it's a requirement. Rewrite each of the following in the radical form. So this is radical form. Again, come to this step again. This is requirement of the first part of the question, and second part is evaluate. Again, move to this. This is 4 to the power 3 whole power 1 upon 2. Find a number whose square is what? 2. So 4 means 2 square. So this is 4, 2 square. This 3 still remains 3, and this 1 upon 2 remains 1 upon 2. Next, this is 2 to the power 3 and whole power 1 upon 2. We can write 2 square into 1 upon 2 into 3. Because students, if numbers are multiply, so there is a, if numbers are multiply, if you write first number with last number, second number with last number, or first number with second number, no problem. So this is 2 to the power 2 and the power 3 and whole power is 1 upon 2. I wrote 2 to the power 2 into 1 upon 2 whole power 3. So no difference between this and this. But the main point is I want to cancel this 2 by 2. What is remaining? 2 to the power 1. 1 into 3, 1 3 is a 3. 2 power 3 is 2 into 2 into 2. 2 2 is a 4, 4 2 is a 8. So 8 is our final answer. Hope you understand. Come to next part, part E. 8 to the power minus 5 upon 3. Again, first we have to fulfill the first requirement. What is first requirement? We want to write the given question in radical form. It's very easy. This is 8 to the power minus 5 upon 3. First we have to write this 8 to the power minus 5 into 1 upon 3. Because minus 5 into 1 upon 3 is minus 5 upon 3. So no issue. But after converting 8 to the power minus 5 to the whole power 1 upon 3, see this. If you see a to the power 1 upon n, we can write root a with n. This is 1 upon 3. We can write a to the power minus 5 root with index 3. First requirement has fulfilled. The second requirement is to evaluate. Evaluation is very easy. Again, start from this, from here. This is 8. 8 means 2 to the power 3. And this is minus 5, remains minus 5. This is 1 upon 3, remains 1 upon 3. Now, write 2 to the power 3, 1 upon 3 over here and minus 5 over here. Because if 2 to 3 numbers are multiply, then there is no issue if you multiply first number to last number or second number to third number. No issue. So this and this both are 100% same. This 3 cancel by this 3 because power to the power is always multiply. What is remaining? Remaining is 2 to the power 1 into minus 5. 1 into minus 5 is minus 5. Now move to this negative indices. If you see negative power, you can write negative power in 1 upon a to positive power. So this is 2 to the power minus 5. We can write this 1 upon 2 to the power 5. 1 upon 2 to the power 5 is 2 into 2 into 2 into 2 into 2. 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32. So 1 upon 5 to 1 upon 2 to the power 5 is 1 upon 32. This is your final answer. And student, you are seeing that I am not using calculator because no need of calculator. These are very easy questions. These are very easy if you know the laws of indices. These are very difficult if you don't know the laws of indices. Okay, last part, F. Minus 1000 to power 2 upon 3. It's very easy. First write minus 1000 to 2 upon 3 is minus 1000 to square into 1 upon 3. Because 2 into 1 upon 3 is again 2 upon 3. So no problem. But this is minus 1000 to square. This is 1 upon 3. Apply rational indices. If you see a to the power 1 upon n, you can write this root a with index n. Here this is under the root minus 1000 square, and this is 1 upon 3 becomes 3 index. So first requirement has fulfilled. Now the second requirement is to evaluate. Again start from here, minus 1000. We can write a number whose cube is 1000. Obviously 10 cube is 1000. So minus 1000 can be write 10 cube, and this square remains square, this 1 upon 3 remains 1 upon 3. So this is 10 to the power 3 into 2 into 1 upon 3. So we can write this minus 10 to the power 3, 1 upon 3 first and 2 after 1 upon 3, because I need to cancel 3 by 3. So this 3 cancel by 3. What is the answer? Answer is minus 10 to the 1 into 2 is 2. So minus 10 square. And square of any negative number, if you see any even power of negative number, the answer is always positive. So minus square is plus, and 10 square is 100, 10 tens are 100. So this is our final answer. So I hope you understand the use of rational indices along the remaining laws, which we have seen in question number 5 and question number 6 in exercise 4B book 3 7 edition. So hope you understand today's class. We have finished the whole exercise 4B today, and in next lecture we will start exercise 4C, where we will be seeing more indices. As compared to this, we will be seeing more complex indices, and after 2C, inshallah, we will be doing past papers of this topic. So hope you understand today's class. Kindly do practice more and more and more, and never forget to subscribe my channel, and never forget to share my videos, like my videos, and share my videos to other your friend as well. Okay students, see you in next class.